Hi everyone, welcome back to Learn with Preeti channel. In the last sections, we have learned about how to create a thread using thread class and runnable interface. In this section, let's learn about synchronization. If you are appearing for interview frequently, almost 3 to 4 interviews, you will face this question like what is synchronization? Synchronization is nothing but it's like multiple threads trying to access the same data object again and again, then we will get data inconsistency problem. The data inconsistency problem is nothing but synchronization. Here we have a one question. I have come up with some 20 plus questions for both static synchronized and then synchronization. So let's deep dive into those questions. This will be really helpful to crack you interview section. First question. So we have a singleton class. There first we are checking. I have private instance available. First I am checking whether the instance is null. If it is null, then I am checking whether the synchronized of this. After that I am checking whether the instance is null or not. If it is null, then I am creating a new object. After that, what we are doing, we have created the executor service with the thread pool of size 2. There I am calling get instance method, and again task 2, there I also am calling get instance. So two tasks we are basically creating using the callable interface. After that we are submitting those two tasks, and then you are calling the get method. Now our job is to check whether s1 and s2 both are same or not. Okay, so in most cases we will get output as true. In some edge cases, what will happen, thread 1 will come here, thread 2 also will come here. As both are running independently, both will see like instance equal to null, and both the threads will end up with creating a new objects. So to avoid this situation only, I have included synchronized block. This will we are allowed to create the object only for the only one thread at a time. Okay, so if a thread is running, it has to get the lock on the current object, and it checks whether the instance is null, then only we are allowing to create object. If the next thread 2 comes again here, it will check the thread 1 is already acquired the lock, so it will wait until thread 1 completes its execution. When thread 2 comes here, it will acquire the lock once thread 1 completes its execution, and it checks whether the instance is null. Instances will not be null for the thread 2, as thread 1 already created the instance, then it will return the instance. By this way only we can achieve avoiding the creation of objects for threads. Okay, so in truth, the two threads mostly we get value as a true. Okay, if there are many threads, we will get output as true, or both instances are same true. Synchronized block ensures mutual exclusion. Only one thread can enter into a time. Okay, even if two threads get instance simultaneously, only one thread is allowed to create instance at a time. That's why when you test two threads, we see s1 equal to s2. In most simple multi-threaded testers, it appears safe. In Java, new singleton is not atomic. Internally, it happens as allocate memory, assigning reference, initialize object. Okay, so for safer side, it always recommended to keep the creation of object inside the synchronized block. Okay, question number 2. So here if you see what we are doing, we are creating the thread. Inside that we have a synchronized block. Synchronized block has to get the lock of the object. There we are waiting. Okay, after that we are sleeping for 1000 millisecond. Then here this will be run by the main thread. Now tell me, what is the execution, what is the output of this one? 1 2 3 4 5. Okay, the answer is nothing but here what we are doing. The moment t dot starts executes, new thread will be created, new child thread will be registered in the JVM, and that is responsible for execution of that is responsible for setting up the priority for a thread. So the moment it comes here, it acquires the lock of the object. Lock dot wait is nothing but the current thread current thread will release the lock of the object and it will wait until some other one notify it. Okay, it releases the lock. After that, here we are waiting for 1000 milliseconds, and then as lock is released here, main thread will acquire the lock of the object class and it calls notify. Automatically what will happen, it will notify the thread which is waiting. Here in this case child thread is waiting, so this child thread will resume. So this is the execution. New thread starts. The moment we call start, it starts a new thread. It tries to acquire a lock because of the synchronized block. If it success, it immediately calls lock.wait. Wait releases a lock and makes a thread wait until it gets notified. Main thread sleeps 1 second. This ensures the new thread almost certainly start and acquire the lock first. If we are not including this one, then order of the thread execution, that is not in our hands. Maybe main thread will execute first or child thread will execute first. As we have included thread.sleep of 1000, child thread will execute it first. Okay, main thread acquires a lock. Here the child thread is waiting and main thread is sleeping. After that, main thread acquires a lock as lock is released by the child thread and calls lock.notify. Notify wakes one waiting thread, but if no thread is currently waiting, then the notify is lost. Okay, so key question is, does notify happen before the thread calls wait? As we have had a thread.sleep of 1000, which means new thread will almost certainly start and enter into the waiting state. Okay, the moment it completes its execution, we are waiting for 1000 milliseconds. By that time, new thread will almost be created and it acquires a lock and it's waiting, releases a lock and waiting. Okay, and it is in waiting state. So yeah, which means the new thread almost uncertainly start and enter into the waiting state before main thread calls a notify. Therefore, the waiting thread will be notified, resume execution. So in this exact code, thread resumed will be printed. Okay, so thread resumed will be printed as an output. Important note, if you remove thread.sleep, there is a chance main thread acquires the lock and call notify before the new thread calls wait. In that case, notify is lost, the waiting thread will wait forever. Then thread resume would never be printed. You're getting my point. So let's say I have commented out this line. I am commenting out this line. Then what will happen? Then what will happen in the sense means then what will happen? Order of execution is not in our case. Maybe consider the main thread acquired the lock and it calls a notify. By the time child thread created and it goes into waiting state, before that itself notify is called, so notify will be lost and child thread will be in waiting state forever. Okay, so moving on to the next question, increment without synchronization. So we have created one task using runnable. We are iterating till 1000 and then we are incrementing the counter. We have created a 2-thread object with the same runnable task with a static in counter equal to 0. We are calling t1.start, t2.start. So 2 child threads will be created. Inside the try, main thread will wait until t1 completes its execution. Main thread will wait until t2 completes its execution. After that, we are printing the counter. So what will be the output here? Are we expecting the output as 2000? We have seen this example in our previous sections. Those who are watching my videos will get this thing quickly in their mind. The answer for this question is counter value will be inconsistent. Why it is inconsistent? Because the same value is accessed by the same multiple threads. Okay, we will get inconsistent value. The counter is not atomic. It consists of 3 types. Read the current value, add 1, write back the result. Let's say both reads the same value 5, both adds 1 and both write 6. We will counter value will increase by 1 instead of 2. This is a race condition. So final output will be less than 2000 and we may it may change on each run. Okay, so how to fix this one without atomic integer? We have, in a previous section we have seen we can use atomic integer, right? So how to fix without atomic integer? Go for a static, go for a synchronized block. Introduce inside the for loop, introduce the synchronized block. It has to increment the counter only when the object got the lock on the current object. Yeah, synchronized test dot class. So what will happen now? This will print output as 2000. Why so? Because let's say thread 1 is coming here, the thread 1 has to acquire the lock on test dot class. When thread 2 comes here, it will wait until thread 2 releases the lock. So output will be consistent. You will see output as 2000. Alternative view of using static method. Alternative way of using is using the synchronized block. Go for static synchronized method. Static synchronized increment, you call increment every time. If we go for static synchronized, it requires it has to get the lock of the class. Okay, so static synchronized method is nothing but you have to get the lock of the class. So there also you will get output as 2000. Okay, so moving on to the next question. Synchronized on wrong object. When we have to go for synchronized, if multiple threads are trying to update same data again and again, then we have to go for synchronization. But here if you see, I have included new object inside the synchronized. Is this correct or wrong? Do we really require synchronization here? No. Why? Because every time, let's consider I am calling t1 dot start up, there I am calling increment method inside the run method. Every time the new object will be created, so there is no chance of data inconsistency occurs here. So synchronization itself is not required here. Okay, so yeah, now moving on to the next question. This most of the people will be familiar, those who are watching my sections. So this is nothing but you have created a new thread, you are waiting for some time, you are running the loop till true, and then you are calling t dot start, and then you are calling t dot interrupt, system dot out dot println of interrupted. So will this thread stop or not? How to handle interruption correctly? So here the answer is thread will not stop at all. Why not? T dot interrupt does not force a thread to stop. It only set the thread's interrupt flag to true. Your thread is running a busy infinite loop, right? Inside the loop, you never check whether thread dot current thread dot is interrupted. So the thread ignores the interruption, keep running forever. CPU may spin at 100%. How to handle this interruption correctly? Using the interrupted flag, like something like this is interrupted, then close. Okay, so yeah, moving on to the next question. Lost wake up, sorry, not this one. Moving on to the next question, question number 7. Synchronized on class versus instance. So here what we have done, we have come up with one new method which is synchronized method and static synchronized method. Then inside the main method we have created this two object, test t1 new test, test t2 equal to new test. I am creating the object t1 dot instance method dot start, t2 dot instance method dot start, and again I am calling static method. Okay, static method with start. What is the output here? If you see, both t1 and t2 are different objects. So to call the instance method, I am calling instance method using two different objects. If you see here, as I am calling two different objects, to run into the instance method, it has to acquire the lock of the current object. As we are using two different objects, it has no restrictions over there. Instance method will be executed simultaneously. Static method requires class level lock. class level lock and object level lock are different. If the object level, if we have a static synchronized method, we are allowed to run any synchronized methods at a time. So the so yeah, so now this is the concept. Okay, now which method blocks each other? Does instance method block static method? Why or why not? Synchronized instance method, we have this instance method, right? Lock acquired, object level lock, either T1 or T2. Each object has its own lock. Okay, do not block each other because they lock different objects. If I call T1 dot instance method, okay, if I'm using the same object, then only it has to wait until the lock gets released by this thread. Okay, as both are different object, then there is no chance of locking. Static synchronized requires class level lock. Okay, only one thread can execute any static synchronized method of the class. Instance method uses object level lock, static method uses class level lock. They do not interfere with each other. So instance method does not block any static method and vice versa. Here if you see T1 dot instance method, T1 object lock. Does it blocks T2? No. Does it block static? No. T2 dot instance method, T2 object lock. Does it block T1? No. T1 thread, does it block any static method? No. If I call static method, it requires a class level lock. Does it block any instance method? No. Does it block static synchronized method? Yes. So the conclusion is, when we have a static method on two different objects, it does not block each other. Static method does not block instance method. Static method would block other synchronized static methods of the class. Okay. So moving on to the next question. This we have seen. Those who are watching my video, you should be in a position to answer this. If you're not in a position to solve this answer on your own, I would strongly recommend you to go and watch my previous section. So if you see, you should be in a position now to answer this one. Will the output of this code is consistent or inconsistent? Inconsistent. The answer is count value we are incrementing inside the synchronized, but after again outside the synchronized block, you are again incrementing the count. So we will always end up with data inconsistency. So to make this consistent, include this count plus plus inside the synchronized block, or use synchronized synchronized method, or use atomic integer. So option 1, go with the synchronized whole, or option 2, go with the synchronized block, or option 3, use atomic integer. Okay, so this is the concept. So far we have seen how the synchronization works, right? So now let's understand a little bit deeper on static synchronized versus synchronized. So here we have a one static synchronized method. There we are waiting for 500 millisecond. Again we have another static synchronized method. There we are waiting 500 millisecond. I have a two test object created. I am calling T1 dot instance method, and after that I am calling static method. Okay. So what will be the output here? Can static and run simultaneously? Answer to that question is yes, because both are. First question is this is an instance method and this is a static method. Static synchronized method locks on the class object. Instance method lock on the instances. Yes, both can run simultaneously because both are different monitors. So there is no mutual exclusion. Now coming to the next question, multiple instance. Okay. Synchronized method I have. There I am getting the thread name, waiting for 1000 milliseconds. After that I am calling T1 dot method. There I am passing the thread name, and then I am calling the start method. Will T1 and T2 block each other? It is synchronized method. To run the synchronized method, we have to acquire the lock on that object. We are calling T1 dot method. To run that method, to run the method, if I call T1 dot run T1 dot method, it has to get the lock of the T1, right? T1. Similarly, T2, it has to get the lock of the T2 object. Both are different objects, so there will be no block. It will run without any problem. So here you can see T1 dot lock on T1, lock on T2. Since T1 and T2 are different objects, they have different locks. T1 and T2 will not block each other. Each thread acquires a different object. There is no shared monitor or lock. Okay. So moving on to the next question, synchronized block on class. So I have a synchronized block, and then I'm creating a two object. They are calling the method. Okay, what will be the output here? How is it different from synchronized on this? Will T1 and T2 block each other? Synchronized dot this is equal to the synchronized instance method, because both lock the current object. However, since T1 and T2 use different objects, they do not block each other. Hope you are getting this point. Okay, it has to get the lock of this object. Since T1 and T2 both are different objects, it does not block each other. Moving on to the next question, what is the synchronized of this? What will happen? Does Java allow nested locks on the same object? And this works because of a concept called reentrant lock. This is like a first level lock. This is second level lock on the same object. Okay, so the thread enters the first synchronized this, acquires a lock on this. Then it tries to enter the second synchronized this. Since the same thread already owns a lock, Java allows it again. Already you are here. You require the lock on the current object. You already want the lock. Why again you require the lock? So you can go inside. Okay. Moving on to the next question, I have static synchronized method and then normal instance method. I am creating a one object. There I am calling a static method. I am creating another thread, one thread. There I am calling static method. I am creating another thread. There I am calling instance method. So instance method is nothing but normal method, whereas a static method is static synchronized method. If any static but inside this instance method, it is a synchronized block. It has to require the lock on the current object. When we run the static method, static synchronized method, it also need the lock on the current object. So both will if static method is running, instance method has to wait until the lock of the current object gets released by the static method. Static synchronized method locks on the test class level lock. Synchronized test block also locks on the test dot class. So both threads are trying to acquire the same lock. Both methods synchronize on test dot class. They are mutually inclusive. If blocking is not observed, it is due to thread scheduling, where one thread acquires and releases the lock before the other attempts to acquire it. Okay. Moving on to the next question. We have a static synchronized method and another class with static synchronized method. So there I am calling this method. When we are calling that method, it has to no threads will block each other because both are different object. Static synchronized requires class level lock. Both are two different objects. There is no contention. Okay. Here I have a one synchronized method. I have one object that is used by both the threads. Okay. I'm calling the start method. After that I'm waiting for some 100 milliseconds. Again I'm calling the start method. So the second thread I'm starting after waiting for some second. The question is here, as I am here, obviously error will be thrown. Okay, will the second thread will be executed or not? If one thread throws an exception inside the synchronized method, can another thread acquire the lock? If yes, why? Answer to that question is another thread can acquire the lock even if thread throws an exception inside the synchronized method. What actually happens if T1 enters the method and acquires a lock of T? It prints. It throws arithmetic exception. An exception occurs inside this block. The method exits abruptly. JVM automatically releases the lock of the object. Then T2 acquires the lock, execute the same method and print starts T2. Okay, then also crashes with exception. Why JVM releases a lock? Because every synchronized block is internally like acquire the lock, critical section, finally releases lock. If any exception is thrown inside the try block, when it comes to finally, it will release the lock. So yeah, in this section we have learnt about how the static synchronized and synchronization are working together. If you guys have any question, feel free to comment on my video section. Thanks for your time. Thanks for watching my video. Have a great day.